What do you mean when you say, I know, I understand?
Interpretation that we have created around quantum physics, that it cannot be understood, and so on and so forth. I try to challenge that.
Quantum particles doesn't understand measurement, and macro particles like us doesn't understand probability. If I say I understand quantum mechanics, it's a false statement, because understanding is a macro thing. I cannot understand quantum world. And the moment I try to understand quantum world through my measurement process, I change it.
Whenever you actually are observing or measuring it, the consciousness has interacted with that quantum particle and thereby changing its trajectory or its motion.
It's not the observed thing. When you measure a particle, measurement is a macro thing. Quantum particles exist without measurement in the superposition state. The observer has no role, in the sense that people get confused about. Consciousness cannot actually independently change the state of the quantum setup. When you try to measure the quantum system, it loses its coherence, it loses its quantumness, and it becomes entangled with the detector, thereby showing you a different reality.
When an observer or detector or consciousness, whosoever, is creating that change or producing decoherence, it is not that it is formulating or creating a new reality, rather it is changing the old reality. Hence, there is only one reality.
Reality is a perception. It is only designed for this biological thing called us. But superposition, although doesn't make sense to us because we cannot understand it. It's not a thing to understand because we don't see it happening in our macro reality. We sort of don't get it. But it's a real thing in the quantum realm. The quantum realm and the macro realm exist in the same place, but we don't have access to the quantum realm. But whether or not we need to really understand it, these are counterintuitive, but that doesn't mean they are not real. They're real. It just doesn't fit into our intuition, our day-to-day intuitions. Yeah, the math tell us this, and we have to shut up and calculate.
Om Shanti, and welcome everyone on this new podcast episode. Today we have a more Renaissance speaker with us. So this is episode 3, and in this episode we will be talking primarily around the quantum physics and how does it overlap and intersects with especially around the Brahma Kumaris philosophy. So a quick intro about our guest. He is Mr. Arnab Dasgupta, and he is a writer. He has written one book on which is Amazon bestseller, 25 career nuggets, which we will shortly talk about. And he is an expert on IT, and he is also a corporate psychologist. And he has delivered many talks, especially on corporate events. So welcome, Mr. Arnab. And first of all, I would like to have a few bits about your experience and life. I mean, because IT and psychology, they are two polar parts. How do you end up landing in these two disciplines?
Thank you for having me here in the podcast. It's going to be exciting. I'm looking forward to it. To start with answering your question, corporate and psychology, in fact, are not two poles. Corporate environment deals with people, and every one of us are different. Understanding how the different minds work together is the core part of corporate psychology. The better we understand the people's mind, how they interact with each other, their shortcomings, the various challenges in the minds of people, and how you have measures to correct them. It lays the foundation of a better future for our corporate employees. Not just corporate employees, it can be applicable to any employees, any workgoers, or anyone in general. I was more fascinated in psychology from childhood. I'm fascinated to understand how the mind works. Started asking questions like, why do we exist? What is consciousness? And all sorts of things. But because of my profession, I got enough opportunity in delving into people's mind. So took a personal dive into understanding reality from people's perspective. Right. I also have a lot of interest in physics, especially quantum physics. Quantum physics, understanding someone's psyche, which is consciousness, plays out very well because of the obviously of the fact that, which we'll touch upon very soon. So those were my interest grounds. And when I started my journey as an analyst 18, 19 years back, I was a silent observer, and I never thought I would be standing in a stage and deliver a speech or even write a book. I was very shy, very introvert, non-talkative. But gradually, when I understood when I took interest in understanding people's mind, that gave me enough hope of bettering it. Right, I felt the necessity of sort of helping people. So that was the initial trigger in delving into corporate psychology and sort of provide a help. A little portion of my salary goes to that fund as well to upskill and bring up the underprivileged guys, who want to come to corporate, but due to some reasons they're financially not stable or can't afford it. So I help them. In a nutshell, corporate psychology is my key interest, and that directly, indirectly connects with the sciences of consciousness and quantum physics and psychology in general. Yeah.
Thanks. Thank you, Mr. Arnab. And I'm really excited to kick off this discussion. But before that, for the audience, so what problem we are going to solve today? So you might have seen a lot of movies, especially in Hollywood movies, where we see that a lot of parallel realities exist. Even in the world of Brahma Kumaris, we say that there is only one reality. Now, because this podcast follows an interdisciplinary approach wherein we try and solve things from a 360-degree view and bring a logical coherence to the overall discussions. So in this talk, we will try and understand some of the principles on quantum physics. We have the expert with us, and of course, we will challenge some of the questions, some of the theorems, some of the aspects of quantum physics to understand it better. And then we'll try and develop the overall understanding that how the quantum physics, the classical physics that we have studied, and the reality that we have, all three are actually part of the same world. In this podcast, how it is going to be happen, I'm going to put my arguments. It will be more towards solving a problem, how it is benefiting the overall society, and of course, it should follow some logical conclusions and derivations whenever we are trying to explain something, right? So quickly jumping to the topic now. So, Mr. Arnab, in your view, how would you describe the double-slit experiment to a non-tech person, and how would you define it?
Right. Well, double-slit experiment is one of the most mind-bending experiments in quantum physics. Right? As we all know, it reveals. It talks about how particles like electrons and photons can behave both as a particle and as a wave. So it's a mystery in physics that both particles and wave exist at the same time. It's called a duality problem in physics, and it happens when you observe a certain setup, and the setup is the double-slit setup. When unobserved, they create an interference pattern, so behaving more like waves. But the moment we observe them, the moment we measure them, the measurement is the word here, the moment we measure them, which slits they pass through, it collapses the particle behaving as particle. In a very layman language, if you have two slits, like two openings, and if you pass a stream of water, it will actually have a similar interference pattern if you observe it at the other end of the, let's say, an obstacle, let's say a wall, creating a crest and trough at the other end of the wall, right? If they pass through the slits. Similar thing is noticed in quantum particles. When we pass particles through slits, the size of the wavelength of the particle, of course, they create similar interference pattern as we see in water waves. It's exciting because other setup generates similar kind of outcome, but they show that particle indeed are dot-like entities. But the double-slit experiment can show us that particle exists as wave. It was Thomas Young who actually conducted the double-slit experiment in 1801, which is, I think, 100 years before quantum mechanics was formally introduced by Planck, Einstein, and Bohr. Later on, Maxwell came in to show that light is indeed a wave of oscillating electric and magnetic fields. So basically, Maxwell showed that light is in fact a wave. Later on, Einstein came along to show that light is indeed a particle in his famous photoelectric effect, where he obtained the Nobel Prize. So Maxwell showing light is a dance of electric and magnetic fields, which is a wave. Einstein shows it to be a particle. So which one do we believe? Well, it appears they both can coexist at the same time. Later on, de Broglie, famously, we read de Broglie's wavelength equations. De Broglie came along to show that just not light. It is matter in general. So he showed it then with the electrons. Light, of course, is not a matter particle. It's a non-matter particle. It doesn't have mass. Photon particles doesn't have mass, so it's a non-matter. Matter, which has mass, like electron, also exhibit the same interference pattern sort of quality. I'll stop here to sort of take your view, Ankur. Does that give a good view of what this setup is, the double-slit experiment is?
Yes, Anand. So, Anand, let me keep it simple for the audience. So, basically, we talked about first that there is a double-slit experiment. So, what is double-slit experiment? Basically, there is a source which emits the quantum particle, and then there is a wall which has only two slits into it, and there is a further screen behind that. You shoot the particle, you observe on the screen that how it is behaving, and the overall, if I simplify what you just said, is that when the quantum particles, you are not looking at it, they form the wave pattern, which is the crest and tufts. And the moment you look into it, you try and observe or you try and measure it, it breaks the wave pattern. Instead, it starts behaving the particle, right? And that is where the whole basis of quantum physics exists, that it is wave as well as particle. That's what in all you said. Now, right. Having understood the experiment, I will go deeper into it when observer actually trying to measure it. Right. So the current interpretation that we have learned in our books, of course, in your talks as well, when you look into it, you break the pattern. So basically, if you are not looking into it, the reality does not exist. Right. And when you look into it, the reality existed or changed. So before we go further, so Arnab, what is your view? Does the reality, when the observer is actually looking into it, is the reality changed or is the reality existed?
It's a very tricky as well as at the same time very subtle topic. It's highly misunderstood experiment and the outcomes of it. Before I explain what it really does to the reality of the particle, I need to introduce a term for the audience. Is called decoherence. Decoherence is a concept in quantum mechanics that explains how quantum systems lose their quantumness. What is quantumness? Quantum particles always are found in a superposition state. It means they can exist in multiple different states at the same time. They can also exist in multiple different energy levels at the same time in the same place. And this is the reality of the quantum realm. It's not because of a limitation of our understanding or viewing the quantum world. It's not because of the limitation of our equations and the equipments that we have. It is indeed a quantum reality. Superposition is natural for quantum particles. Well, superposition also applies to us, and I'll talk about it, how macro beings sort of tend to decohere and lose that quantumness. So decoherence is a concept that shows how a quantum system lose their quantumness. Quantumness is the superposition state. What happens in the double-slit experiment? When you pass on the individual particles through the slits, it shows the interference pattern, which is absolutely the projection of quantum mechanics. They are in a superposition state. They will definitely show the wave-like quality. But the thing is, when you sort of introduce a detector in the doors of the slits, the same particle now behaves like a particle. It really shows you on the other side of the screen as particle, like a dot.
Correct.
It breaks the interference pattern. It loses its quantumness. It collapses to a wave function. What it means is when you observe or when you measure, it's not the observed thing. When you measure a particle, measurement is a macro thing. Quantum particles exist without measurement in the superposition state. When you try to measure the quantum system, it loses its coherence, it loses quantumness, and it becomes entangled with the detector, thereby showing you a different reality. I'll get back to this in a bit. Let me give a very high-level layman overview of what it means. Let's say I'm looking at you at this moment. It's simple physics. Basically, light is hitting you, and then it's coming to my retina, and I can see you in my optical lens, the biological optical lens. But if I shrink you down to the size of an electron, and if I want to see you in the similar classical sense, what happens? The light ray, which is a photon particle, will hit you and will move you out from that location. Because you're a quantum particle, you're an electron now. It can change your location. By the time it reaches my eye, by the time I can see you or observe you, I'm not looking at you in your position. Basically, I'm looking at a different reality.
Correct.
So I cannot measure or observe quantum particles. I will always change their state. It's the limitation. The limitation is we will always break the quantumness of a quantum system when we try to measure it. A lot of people get confused when they talk about observer observing and observer measuring. So if I simply look at it, it will not collapse the wave function. I will have to measure it. And measurement devices are physical setup that are uniquely built to break the coherence. And it can be placed in the detector. If I go in the detector, if I go in the slits and stand there, I cannot break the coherence. Because this physical system doesn't have a detector. I don't have a measuring device inside me. I can be conscious, but I don't know how to see a quantum particle. The detector can see a quantum particle, and thereby it will change its state. So basically what is happening here is, Ankur, when we pass through quantum particles through the slits and we try to measure them, that is where we change their state and we see the collapse. The observer has no role in the sense that people get confused about. Consciousness cannot actually independently change the state of the quantum setup. It has to be the detector. Now, the second question can come up. What is a detector? It's a macro thing, and decoherence happens when quantum system interacts with their macro things like air molecules are much larger than the small quantum particles. It interacts with air molecules, interacts with the metal, the body, and everything, right? Those also can contribute to decoherence. But the problem is those can contribute only so much. But when we do a carefully designed setup like a detector, it is actually there to break the quantumness of the system. So this body, although very complex, cannot do much in breaking quantumness because we are not detecting it, right, measuring it. So I'll pass it on to you to see more questions.
Yeah. So Arnab, again, I will have provide more explanation to my question and what is that I'm trying to say and what is that I'm trying to implicate. Same example, you said that if you're looking at me, if I got squeeze at a quantum level, and the moment you look at me, my sensitivity increases, right, towards the rays that I'm getting, correct? And by the time those rays eventually reaches your retina, I will change my position because I am sensitive to that rays, right? And that is where my contention lies, is that the superposition principle says that if you're not looking at me as I am being the quantum particle, right? If you're looking at me, I exist at multiple places, in multiple states, right? That is superposition, and that is the multiple realities, the basis of multiple realities. But in this example that you just gave, even if you were not looking at me, right? I was only at one state. When you looked into me, you changed my state. So in nutshell, what I'm trying to say, when an observer or detector or consciousness, whosoever, we park that question, is creating that change or producing decoherence, it is not that it is formulating or creating a new reality, rather it is changing the old reality. Hence, what I'm saying is that there is only one reality, and plus the variable part to it that affects it, maybe we can say that the detector, the consciousness, whatever it is, but the reality remains only single reality. I mean, there is only one reality.
Absolutely. I can completely agree with you. I mean, this is where Einstein, sort of was very tensed about.
Correct.
Quantum mechanical, individuals were going in the wrong direction, giving it a probabilistic sort of definition, and he always wanted to define reality as absolute. In fact, indeed, reality is absolute. But the thing is, there are different realms that exist within this reality. Now, one is a quantum realm, where we have no access to. The moment we try to access them, the moment we try to see them or measure them, we change it. We change the same reality. I'm not saying we are looking at a different reality. We actually alter the reality.
Correct.
We change the quantumness of it, because quantum particles doesn't understand measurement, and macro particles like us doesn't understand probability, right? We cannot see probability, right? We cannot.
Correct.
How
Abstract.
It's an abstract. If I say I understand quantum mechanics, it's a false statement, because understanding is a macro thing. When I say understand, I will say that I understand biologically, intrinsically, that one electron can be in multiple states, or one electron can be in different spin up and spin down, right? Let's say. I can't understand it because it's not my realm. I don't feel it. I'm looking at you right now. I have a sense of feeling, speaking with you, there's a setup that I can see at the back, in the background. So these are my feelings, and I understand those feelings because I'm sitting in the macro world. I cannot understand quantum world. And the moment I try to understand quantum world through my measurement process, I change it.
Correct. So all in all, and another thing on the superposition that I have is that because see, I am in complete agreement, the experimental setup that you described, I am only putting my thoughts especially on the interpretation part. How do we interpret from this experimental setup? And that is the whole point that I'm trying to put forward, is that one, there is single reality, and two, this concept of superposition that it brings is that the particle exists in multiple states. That itself is contradictory in a way that if this is to be true, then we cannot conduct any quantum experiment because we cannot achieve a vacuum, right? See, the very, very first requirement to conduct any quantum experiment is to have the vacuum. Of course, we cannot have the perfect vacuum, so we have to, push it to the limits. But if superposition is to be considered as true, then all the particles must exist in their multiple states. That means no matter what we do, we cannot achieve vacuum. So this, in nutshell, I may conclude that the interpretation that we have got on the superposition is I feel something, probably more work needs to be done, or probably our understanding is not that correct.
Let me quickly jump to this. When you say you need a vacuum, let's talk about super or quantum computers, which are at work in pace basically by IBM and Microsoft and other companies, right?
Absolutely.
They have and are designing quantum computers. What it does is basically, we don't need to sort of manipulate the quantum world to have an outcome. We simply can live the quantum world the way it is, like they are in a superposition state, and we're deliberately using that superposition state to sort of create the quantum computers. The quantum computers uses the superposition idea, and if the superposition is not a valid idea, our quantum computers won't work. We have a physical quantum computer working simply on basis on the superposition theory. Now let me add more to it to clarify the points. The main challenge of having a good built quantum computer is that maintaining the superposition state. What happens is this quantumness decohere, right? It goes away. The quantumness goes away very quickly when it interacts with the circuitry, the temperature inside the CPU, and all sorts of things, right? As I explained, that the quantumness goes away if it comes in contact with macro setups. So if you go and look at the quantum computer labs, you will see temperature to the degree of minus 20, 30 degrees. You have to cool the room or the entire setup to such a degree that you can achieve almost close to absolute zero. Mm-hmm. When you achieve absolute zero or close to absolute zero, you have lesser movement in the molecules and atoms, thereby allowing quantum particles to possess their quantumness and superposition. And you can have a working quantum computer. As long as the quantum particles are superpositioned, we can have a good quantum computer. Now, you will say, how do we get an outcome, macro outcome in the screen? Outcome is macro, right? And that's where you go, that you have the entanglement. The setup is designed to collapse the superposition in a certain way that I can show the outcome in my macro screen when I want to. So superposition exists in collaboration with entanglement in a quantum computer. The same theory works, we will probably talk about it later, in the consciousness theory, where Dr. Penrose is proposing, and I think the IIT theory also sort of hinges on it, is how to use that to generate a conscious one feeling. But I'll talk about it later. But superposition, although doesn't make sense to us because we cannot understand it, it's not a thing to understand because we don't see it happening in our macro reality. We sort of don't get it. But it's a real thing in the quantum realm. The quantum realm and the macro realm exist in the same place, but we don't have access to the quantum realm.
So, Arnab, and thank you for that. I haven't read too much on the quantum computing. Probably that's a miss on my part, so I'll look into it. But what I understand is that you're saying if superposition principle is to be considered incorrect, right? Then let's, for the sake of our discussion, then we cannot have the quantum computing because are they using in a way like, let's say, if I have the particle A, and they are able to use multiple states of particle A. That's what you're saying?
Exactly. Now, we are communicating using a computer that uses 0 and 1. Two states.
Right.
Two states, right? And we have achieved this limit of speed. Imagine, quantum computer uses qubit, and qubit can use multiple states at the same time because a quantum particle can be in multiple states. And we can actually use this technology to speed up the processes within a system. It's not just 0 and 1. It's like everything between 0 and 1. So like 0.001, 0.002. It's infinite states. And imagine the number of states that we can achieve in doing the calculations, and imagine the speed it can achieve with having this. And we use it to build super quantum computers. Yes, it's completely dependent on superposition, quantum computers.
Okay. Because recently I was working on NVIDIA GPUs. So basically, we were trying to deploy the chatbot, and the GPU is primarily around the parallel processing. Basically, CPU gives the serial processing, GPU gives the parallel processing. And I will check back and confirm, probably we can have another on that, whether the quantum computing, and I'm precisely repeating it so that I understand it correctly, is that there's only one particle, it is being shot in the system, and its multiple states are being used, right? And because we can control how much we are measuring. So basically we are controlling to make sure that we are not collapsing its wave function, and that's how we are trying to use this, right?
And we deliberately collapse the wave function when we want to bring the outcome in the screen. We have a definitive outcome in the screen, but we have the control over collapsing it. That gives us the power. Now, Ankur, your double-slit setup actually shows an interference pattern, a wave-like pattern, and that exists, right? Independent of the measurement, though, but it still exists. There you go. I mean, you see a wave-like thing exhibiting by a particle, and this is probability distribution. Basically one particle can be in multiple different places and multiple different states, let's say. It's just that we don't know which state they are in before we look at it. And it is again not a limitation, and we don't understand it. What I'm saying right now, I don't understand it because it's my brain cannot comprehend it. But the mathematics says it, and the mathematics works because quantum computer works, right? It just works, but we don't know why the quantum realm the way it is. It is incomprehensible. It is not intuitive. It doesn't fit into our intuition, but it's a separate world that we have no access to. The moment we introduce a detector or a measurement system, which is a macro thing, we understand it because now we have introduced a measuring device. It's our thing, and we have changed the quantum realm altogether.
Okay. Because Arnab, one thing on the Heisenberg uncertainty principles, right? So basically, it says that position and momentum of a particle cannot be calculated, right? So first of all, my check with you is that I have read the Heisenberg book that he has written. So is that the capability issue, or is it impossible by its fundamental nature? I mean, capability, when I say, let's say, 5-10 years after we have good control on AI, we have progressed well in terms of technology, would we be able to do that? That is capability. And fundamental, when I say, no matter how much progress we make, right, even if we have the aliens coming on Earth with, having technology much 10x or 100x what we have today, even they will not be able to do it. So which one is true?
Heisenberg's uncertainty principle is a core component in the nature of reality. It's as if 2 plus 2 is 4. You don't need to change it because that's reality. You cannot measure both speed and position at the same time. Now, let me try to give you an analogy here. You try to take a picture of someone with a moving background, speeding cars in the moving background. The more you try to focus on this subject, which is, let's say you're taking a photo of your friend, the more you try to focus on your friend, the less you have control over the moving cars at the background, right? You have a blurry background. And the more you try to increase your shutter speed and take the snapshot of the moving cars, you lose your friend's vision. It is how it is. And we will never achieve a camera that can take both things at the same time. And no, I'm not saying that. This is just an analogy. What I'm saying is you will not be able to ever measure position and velocity at the same time. It's how the universe works. And it's not a limitation to our capacity of designing a device that can measure it or a super intelligent that can finally figure it out. We have figured out a very basic property of nature, which is the Heisenberg's uncertainty principle. And this is reality. Again, I'm saying these are counterintuitive, but that doesn't mean they are not real. They're real. It just doesn't fit into our intuition, our day-to-day intuitions. The math tell us this, and we have to shut up and calculate. They use a word called shut up and calculate. Don't try to make sense of it because they work. We have devised so many technologies on the basis of these fundamental theories. If the devices or the equipments that you see around you are working systems, then the theories must be true, right?
Correct. See, because and you wonderfully explained that. I must congratulate you on that. Again, you explained it with the help of an analogy. Now let's talk about the example that you gave earlier. For example, you shrinking me to a quantum level, and then when you look into me, by the time it reaches, I will change the state. Why I do not find it that difficult? Because in our IT world we have similar thing called latency, right? When a user is actually logging in, and by the time it gets the response that you are allowed to do that, there is some latency to it, right? And we try and measure it, and we try to come up with some countermeasures and so on and so forth. Similarly, what my argument or point of view is that same example, if you shrinking me, and so rather than we looking towards the solution of it, right? So basically, if the measurement or your consciousness is causing that change, right? We should look for that particular variable, right? How the measurement works. I will talk about some of the consciousness as well. So rather than we should say that, okay, how does consciousness is interacting with the physical world? Right? Because we know we are consciousness and we are interacting with this body, so that happens. So rather than we say that we study on this aspect, instead when we say that we cannot measure, or it is impossible to measure both the entities, position and momentum at the same time, considering science is also a stream which is always evolutionary, right? It is always progressing. Whatever we know yesterday, may not be true versus what we know today. So in these three aspects, now what is your view on Heisenberg uncertainty principle?
No, I completely understand the misunderstanding here. The problem is that we try to make sense of quantum mechanics, and that's the first problem. It's not sensible to understand quantum mechanics with this mind. We are not designed. Our macro bodies have evolved to use a particular band of light. Light has got multiple bands, right? In the visible spectrum, we only use one particular band because we only need it. I need it to see you and the objects around me, and that's sufficient. I use the audio band in the frequency of 20 hertz to 20,000 hertz, right? But then audio frequency is huge. But it will not make sense if you give me the entire band. It will not make sense if I have access to the entire band of visible spectrum, like VibGeo, right? That thing. If I have access to all of it, you know how it will look like to me? It will look like a hazy screen. The reality will look jumbled up. Reality is a perception. It is only designed for this biological thing called us, so that we can sustain in this atmosphere within Earth. It's particularly evolved to come to sort of experience this. The moment you try to introduce all the other variables, you lose sense of it. Quantum mechanics and their settings and their activities, their system falls far, outside of our general day-to-day capacity of understanding things. Heisenberg's uncertainty principle is quite a useful theory, and on the basis of it, we have a lot of other theories standing, using it as a pillar. It's as if like saying, 2 plus 2 is 4. Let's have an open mind and let's dive into it to further. No, 2 plus 2 is always going to be 4. I mean, I feel there is no necessity of breaking 2 plus 2 equal to 4. It's there. It's just that it's not there in the realm that we understand. It's like a moving particle in space-time, and space-time is always expanding, always. There is no one moment of static thing here going on, right? Space-time is always moving.
Correct.
If you want to tell that this particle has a position in space here, the moment you have told it, you had to stop this particle, isn't it?
Mm-hmm.
It's an overflowing dynamic universe. When you say, okay, I will measure its position, you will have to stop that particle to see where it is. Otherwise, you have to allow its speed. And the moment you measure the speed, it's always changing position. So to comprehend that I want to measure both speed and position at the same time, it's not a valid question. Did it make sense?
Yes. So, in fact, let me share some of my views on, how does the consciousness and these things come together. So, as a part of my research, latest paper, I was just going through it. First of all, some of the different views that I am holding is that one, and which is I tried to highlight when we started the podcast, saying what are the guidelines, is that one, whenever we call something a science, we need to make sure that it solves some of the problems, societal problems, and it should be able to answer questions in a logical way, right? So I know for quantum physics, it is often being said that, if you say that I understand quantum physics, that means you haven't. That is yeah, that means I'm lying. Yeah, correct. So that is the my view is that this interpretation that we have created around quantum physics, that it cannot be understood, and so on and so forth. I try to challenge that in my mind. If I talk about IIT theory, integrated information theory and consciousness, which basically means that the current theory on IIT says that consciousness is all about experience, right? It uses all the information, whatever we have in our around, and bases that it processes it and creates an experience. That is the IIT theory. Right. If I talk about Brahma Kumaris go one level deeper to it. It says that consciousness is not just about experience, rather it is further has 3 faculties into it, which is like ability to create thought, because if I do not have the thought, there is no point of having experience. You cannot have that, right? And then of course the knowledge, because in order to experience something, I need to know that knowledge. So for example, if there is a Mona Lisa painting given to you and given to me, considering you have the complete understanding how rare it is, how delicate it is, you will be able to experience you will have much better experience considering me if I do not know anything, right?
The red of the redness, right?
Correct. Right. Yeah. And the third aspect is the kind of emotion. So whenever we have experience, you get different experience when you have Mona Lisa painting in front of you versus if I am eating my favorite cuisine, right? So the emotion also matters. So right. In the same way, so whenever consciousness is actually creating a thought, it generates, and we know that our body has the electricity, right, to some lower voltages. So whenever that consciousness creates a thought, it produces the electromagnetic field, which actually interacts with the physical world, which also happens in the double-slit experiment as well. Whenever you actually are observing or measuring it, the consciousness has interacted with that quantum particle and thereby changing its trajectory or its motion, which we say that from wave to particle. And that is how I at least define in my mind that consciousness. So basically how consciousness interacts with the quantum particle, and that is the same to some extent the principles of quantum classical physics as well, right? So this interaction overall happens because I was going through, I told you the book by Heisenberg, how he described the position and momentum, they cannot be calculated. He said that if I pass a ray from, say, liquid A, which has the different density, of course, it will have the refraction and reflection. Similarly, if I pass it to a different liquid B, it will have the different density and it will have the different refraction and reflection. Basis on that, he came up to say, in his words, what I have read, I can put that for the viewers into the comment section as well. He said that because of the language barrier that we have, and you also kept on saying that, it cannot be explained. Similarly, he has also said that because of the language barrier we have, we cannot define that, position and momentum that can be measured simultaneously. So basically, what I'm trying to say, the consciousness, quantum physics, and classical physics, they all three come together if we try and solve the overall problem that we have manifested with the superposition concept that we brought in. That is my
Ankur, I just want to correct a few things here.
Sure.
I know you have been saying measuring and being conscious is the same thing. When you're saying consciousness is changing the quantum state, it's actually not the consciousness that is changing the quantum state. It is the measurement of it that changes the quantum state. You're basically being conscious of the outcome of it. I mean, our consciousness doesn't take part in changing the quantum state. It is the measuring device that changes it. If this is clear, then we can actually take off this misunderstanding about consciousness from the double-slit experiment. The Copenhagen interpretation is an old interpretation, and that doesn't clearly explain how the observer effect come into play. It just says the observer effect. The recent interpretation clarifies it and solves it by saying it's the measuring device. I will quickly come back to your consciousness question or statement. I just want to fill the gaps before I move further. I want to clearly call out that quantum mechanics has nothing to do with consciousness.
Okay.
And this is not something that I am saying. It is something that the researchers of this age, and they're right. I mean, see, to have a double-slit experiment in 1800, it is obvious to have people getting confused. Good scientists like Bohr, Planck, and Maxwell themselves have written more about the conscious observer. We have to give them benefit of doubt because it's like 200 years back. And our science has evolved now to understand that it is the measuring device that changes the state. There is no empirical evidence as to consciousness affecting even if you're not looking at it, the measuring device will simply record it as a particle. All you have to do all you have to place is the recording device in the slits, right? Even you don't have to be there as well as a conscious observer. Now, this measuring device is deliberately designed to measure, and that changes it. Not the consciousness. But obviously we have consciously devised it. You can say that. Okay, so this one thing. There's another called many-world interpretation, which can slightly touch the things that you're talking about, is that it can be very much possible that when you throw the quantum particles through the double slits, you never know which slit it has gone through, right?
Correct.
It has gone through both the slits at the same time. That's what superposition says, right?
Correct.
But the moment you observe it, sorry to use the observer. The moment you measure it, that's the confusion.
Yes,
the moment you measure it, you know which slit it is going through, right?
Correct.
It means it is all the time going through both the slits. One in this world, another one is in a separate world altogether. It is not this reality, it's the other reality altogether, which is not part of this reality. Both the things are happening. One is happening here, another one is happening here. As for many different states of an electron, all the states exist in all different universes. It's the many world interpretation. It is also a theory. Obviously, it cannot be tested, but which sort of talks about multiple realities. But to clarify, we can definitely talk about consciousness and the way it is, what it is, and what are the recent theories. But I want to, as a science person, I want to call out that the double-slit experiment, quantum mechanics, has nothing to do with consciousness. Yeah.
Yes, and I completely agree. See, even if we eliminate the consciousness part, see, my whole focus is on only the superposition principle. Even if you take consciousness out of, I'm all right with that. If we say that, okay, the detector is causing the whole problem, I am all right with that. The detector is causing it, I am still all right with that. The only point that I am constantly emphasizing is that the reality existed even if before we had the detector, and detector has just changed the reality. It has caused a new reality. It has not formulated. It has not formulated any new reality. It just changed the already existing one. So hence, there is only one reality. That is my whole point. Which
Absolutely. Ankur, on the same context, can I ask you one simple question?
Absolutely.
What do you mean when you say I know, I understand? What do you mean when you say I understand a certain thing? What do you mean by that? It's on a very general level. But then,
Okay, so considering we are discussing quantum and consciousness, so this question is a lot more deeper. So when I say I understand, that means the thought pattern that I have. Let's say for a topic, let's say X topic we are talking about, X discussion we are having. For that X discussion, I am able to understand the patterns, logic of that discussion in my existing thought pattern, and I am able to deduce it logically. So, it is giving me some emotional satisfaction, or so basically I'm going around same principles that I earlier talked about on the consciousness. So basically there are thoughts, the knowledge that I've used, whatever discussion is going on, and whatever pre-trained knowledge that I have, and synergizing both, the final outcome is the emotion that I am getting.
right. And let's say if you were a bat, right?
Mm-hmm.
During night, and if you are just Ankur being a human being, and when you say I understand during night, there is something standing up there, but I can't see it properly. And as opposed to a bat saying I can clearly see it, I understand what is there. What is understanding in that context? What are you using to understand the same thing? Because you don't have proper vision during night, as opposed to a bat. Bat uses frequency to sort of
Correct.
not real vision.
It can see in the dark, yes.
Yeah. So his understanding, or the bat's understanding, as opposed to your understanding about the same thing, can differ based on the setup. Your setup and the bat's setup are different, and you are understanding the same reality in a different way. So when we say we understand reality, we understand based on how this is set up.
Correct.
This setup is not the ultimate setup. That's where we are. So the phi in your IIT theory, we have put ourselves at the top. That's the problem I have. I mean, how do we know? This is not the ultimate setup. This is the ultimate setup we know of so far. We haven't seen anyone else. So that's the search we need to continue, I think.
Correct. See, in fact, you raised a very beautiful point and valid point on the what is reality, right? So I think for the benefit of the audience, we had this long discussion.
Yeah, I know.
So we should define onto the what is reality as well. So reality. And then, of course, you can share your own views as well. See, for me, reality is, say, going by your example again, I cannot see, but bat can see because it's night, right? So the reality is the arrangement of the physical world, how they are placed, right? And the perceived reality could be different. For example, I may have the different reality. I see all dark, right? But if you compare my vision with bat, the perceived reality for the bat might be different. But again, I am only to the point that the bat and myself, we are not creating two separate realities. That is, see, we are both in the same reality. Perceived realities could be different, right? I am absolutely aligned to that.
There is an absolute reality that lies.
Correct.
Exactly.
Correct. And perceived reality is a subset of the absolute reality.
Correct. Now here to extend it more, I completely agree, and I think we are in complete agreement that there is an absolute reality whatsoever. Right?
Correct.
And that can never be perceived because we will always have this mind to perceive it, and different other organisms will have different setups of mind.
Correct.
Now, physics obviously tends to get access to the absolute reality by using mathematics. So can I just take my word back, which I just said? We can. We can sort of.
It is science. Yeah, we can do
science, right? We can have access to absolute reality, but whether or not we will understand what it says is my thing.
Right.
Our math can tell, okay, this is the math. Okay, this is what it looks like. But then this mind doesn't understand it. I have found it. I can use it in science. I can build certain things useful for the society, but will I understand it? No. The theory, I will not. But can I reap the benefit? Yes. Because I am using the raw, fundamental, absolute reality. And I think further to it was a question that I just remembered, something very intriguing that I just forgot. It keeps happening to me when I age. But yeah, but that's the overall thing. I completely agree with you that there is an absolute reality that exists irrespectively, and the universe doesn't care.
Correct.
It doesn't care. It is just there. How we perceive it, it doesn't care. But your other question about how we use science for our benefit, you mentioned for our benefit, for our societal
benefit. Correct.
So you will have to use this set of mind, right? Because if you consider the all reality, it will not be needed.
Correct.
You're not designing a world for the bats. We're designing a world for the human beings. So even though absolute reality's outcome is needed, but whether or not we need to really understand it, I don't feel, because we will waste our time understanding it, because we will never understand it. I'm agnostic about it.
Yes.
Yeah.
Cool. Yes, I think Arnab, it was really nice to have you on the panel, and it was really intriguing discussion that we have, and really, you gave insights to the quantum world. Thank you so much for that, and to the audience. Hope you like this particular episode. We'll come more onto the consciousness part. So Arnab, before we close, if you want to put any closing comments from your aspect.
Sure. And based upon the discussion that we had today, I thoroughly enjoyed it, the discussion. The only appeal that I have for the audience or whoever is watching this video is to keep your mind open, to question, and to understand whether that question is right or wrong, right? Not all questions are right, or not all questions are even required. The thing is that don't clutter your mind with the jargons that are there in the world. And the only way we can do it is through knowledge, deep understanding about a subject. Invest your time in understanding a particular subject, and you can sort of extend and contribute from your side, extending it. But understanding is, again, a human thing. There is beyond understanding. Knowledge is not the entire thing. Knowing certain thing is a human thing. It's a biological urge to sort of know what is the surrounding, and this is not the ultimate thing. Even though it's the ultimate thing for us, we need to sort of appreciate the fact that there are millions of other things available outside of us that we have absolutely no knowledge about. Again, I'm using the word knowledge. And again, knowledge is an attribute fixed to the human mind. So have an open mind. Don't consider any knowledge as the final, and then exploring. Yeah.
Okay. Thank you, Arnab, for your time. Thank you so much. We'll repeat again. Yeah. Thank you.
Sure. Thank you very much, Ankur. Thanks for hosting it.
Thank you. Bye-bye.
Thank you.